this problem, we are asked to find if a string could be concatenated into the words in the dictionary. So the input of this function will be a string, and it's a list of string. So that will be the input of our function, and the output will be a boolean that represents whether the string can be concatenated by the words in the dictionary. So the high-level idea to solve this question will be to use the DP method. So we will use a 1D memo where we call it MI to represent whether the first I's letter in the string can be concatenated to the words in the dictionary. So let me write it down. Can be concatenated into words in the dictionary. So for example, when it is M0, it will be an empty string. So because we will consume it, we will treat it as a true because it can be concatenated by any words, which means like zero appearance in any words in the dictionary. And for then the next case, this is our MI, so M0 and M1 here, and I won't write those. So for M1, we will check L if L will be concatenated in the words in the dictionary. We will first see if the left side, which is the empty, can be concatenated to the word in the dictionary, and the current words, which is current letter, which is L, can be concatenated into dictionary. So the answer is false because we do a manual check to see if the dictionary contains a word of L. So we just have a false right here. And then the same goes for LE. We already know the answer for, so we have two cases for LE, whether if LE can be concatenated to the words in the dictionary, or whether L can be concatenated to the words in the dictionary, and E can be concatenated into the words in the dictionary. So either this case, if that come true, we will just give it a true, but then like we can see we manual check LE, or we manual check L by reading through our memo, and then see the E, it cannot be concatenated to the words in the dictionary. So we will just have false right here. And the same goes for LEE. We have like 3 ways to cut this. So L, like we can either manual check LEE, or we can check L and by manual check EE, and then we can have LE, and then have the E right here. Or we can just do a manual check for LE, which I have demonstrated this example right before. So then we check all the cases, so we can know that all of them cannot be concatenated into the words in the dictionary. So we will just give it a false. And then we go for LEE, LEE. Yeah, I think it's this part in the memo right here. And then we will go LEET, and then we will divide them into a few cases, which is LEET or LEET, and then LE and EET, or LEE and T. So by reading through these 4 cases, we can see like the first case, which is LEET, we can definitely manual check them, and they were the words in the dictionary, so we will have a true right here. And the same goes for those, we do the same stuff and check each of the cases that can divide the current substring, and then see if there's any case that satisfy that both of they were the concatenation of the words. So finally we go to see LETCODE, and we do have one case which is LET, and then divide them to code. So these 2 parts, by reading through our memo, we can get the answer for whether this like prefix can be concatenated to the words in the dictionary. We can read this part of the memo, so we can just give it a true. And by reading the code, we just manual check the dictionary, and it's also true. So our final answer will be true. So the time complexity for this problem will be n squared, where n is the length of the words of the current of the like input string, because we were doing a linear scan each time when we fill the memo, so it will be n squared, and the space complexity will be O(n), where n is also the length of the input string. So that's my idea to solve this question. So in terms of the code, we firstly have a Boolean m that represents whether the first S letter can be concatenated into the words in the dictionary as demonstrated here. And our M0, which is the empty string here, should be firstly assigned to true, because we have it to be true in order it can be formed by words, 0 words in the words dictionary. And then we just fill the memo by having the I. So then we linear scan, look back to see like whether the previous cases that can form the words in a concatenation. So MJ is the is reading our memo that whether the first like J's letter can be formed in the dictionary that we have recorded. And this part words dict contains is manual check whether our new substring can be formed in the words in the dictionary. So if both of them satisfy true, like we have the lead code this case, if like lead is true and code is also true by manual check, so we will have the IMI to true here, because either the way we divide this this current substring will make it true. So either case, if that satisfies the condition, we will make it true, and we just do not need to linear scan and look back anymore after we found one case that satisfies the word concatenation condition. So finally, according to our definition, we are gonna see whether the first S dot length letters, which means all the letters can be concatenated into the words in the dictionary. So we will just return S dot length. So thank you for listening.